So what we're going to demonstrate today is how to apply Pythagoras' theorem to some worded problems, something that we generally find a little bit difficult. Now, in the real world, we're not going to get nice textbooks where we can answer the questions. We're going to be faced with real-life problems. Now, being able to apply the mathematical concepts, such as Pythagoras' theorem, to these real-world problems enables us to utilize math to help us out. So let's have a look at the first question. The size of a TV screen is described by the length of its diagonal. If a flat screen TV is 58 centimeters wide and 32 centimeters high, what is the size of its screen? Now, the first thing that you need to do with this is turn these words into a diagram. Makes the whole process a lot easier. Now, it doesn't need to be a terribly neat diagram. You notice how I'm not using a ruler. I just need to get the general idea. Now, it's 58 centimeters wide. Let's put that piece of detail on my diagram, and 32 centimeters high. Now, what is the size of the screen? The screen is described by the length of the diagonal. So, put my dotted lines. We're trying to find out this red dotted line. Now, how can we do this? We know that this is a right angle triangle, which means this is going to be C. So what it's really asking, okay, I know I can apply Pythagoras' theorem because it's a right angle triangle. So all I need to do is write out C squared, okay, which is the hypotenuse that we're trying to find, equals 32 squared plus 58 squared. Now I can rewrite this to save time by putting a square root in front of it and getting rid of the squared C, and put 32 squared plus 58 squared directly beneath that. So I can put this whole equation straight into my calculator to get me the length of the hypotenuse. Okay, it's just a bit of a shortcut way of doing it. So let's do that. Now you notice how I wrote it out all first and then I came to the calculator. Okay, very important thing to do. Okay, so 66.24. Okay, now we're thinking about it. I've never heard of a TV screen being described as 66.24 centimeters or 78.25 centimeters. We usually round it to the nearest whole number. So the nearest whole number in this case is going to be 66. It's closer to 66 than what it is to 67. So I'm going to say 66 centimeters is the size of the TV screen. Okay, like so. So nothing, we've learned Pythagoras' theorem. We know how to do it once we've got the numbers. What the trick is drawing an accurate diagram to reflect what is being stated in our short paragraph. Let's have a look at the next one. A tower is supported by a wire that is 20 meters long and attached to the ground 10 meters from the base of the tower. How high up does the wire reach up the tower? Again, let's get out our diagram. So I need to draw a tower. Again, does not need to be a work of art whatsoever. Okay, a tower is supported by a wire that is 20 centimeters long. Okay, so we've got a tower, it's attached by a wire, okay, that's 20 meters. Now the wire is attached to the ground 10 meters from the base. So this is my base, the wire is attached there, this is going to be 10 meters. What is my question asking? How high up does the wire reach up the tower? Okay, so what I'm going to be trying to find is, let's call that B. Okay, now as we can see, this is a right angle triangle, like so, which means because it's a right angle triangle and I'm trying to find the shorter side, I can apply Pythagoras' theorem. So I know what C squared is, okay, it's 20 squared equals B squared plus 10 squared. Now let's rearrange this whole thing. B squared equals 20 squared take away 10 squared. I know I'm going to need to square root it, so let's do that stage now. 20 squared, take away 10 squared. Now I've got that working out on my piece of paper, and I've subtracted in my head, I can come to the calculator. No point going straight to your calculator when you haven't got it clear in your mind. You're more likely to get it wrong. Okay, so it is 17.32. So if we have a look, meters, so I can say that, okay, how high up does the wire reach the tower? The wire reaches up the tower 17.32 meters.